Really great to have you again for this second session. It will be quite interactive at the end because we'll get to try to help a few of you to actually like try to install the tools you need to have, like the DFX, and try to like spin up something. It's also good to have that in the recorded video so that others can get better understanding of how it's going. But yeah, we'll do that towards the end. But we just want to talk a bit about the terminology on the internet computer. So we will watch a tutorial together that is like explaining this in more detail, and then after that, we do a Q&A, and then we get into setting up the local environment, the development environment locally or whichever way you prefer. So let me share my screen.
Hello, everyone, and welcome back to the Internet Computer Developer Journey. My name is Jessie, and I'm going to continue to be the guide on this developer journey. In today's module, 0.2, Internet Computer Terminology, we're going to look at the definitions of some of the terms and tools that we'll be using throughout our developer journey. This will help provide additional context and understanding as we move through our developer journey, so we're comfortable with everything that we're working with and developing. In our first episode of the developer journey, I went over a brief overview of what the Internet computer is, and I mentioned a brief definition for some of the terms that we'll talk about today. However, today we're going to take a deeper dive into a lot of these terms and look at some in-depth definitions as well as some visuals to help visualize what these terms mean and how they're used in the Internet computer ecosystem. As a reminder, all of our developer journey videos have accompanying written documentation. And as a brief reminder, I will show you how to get back to that documentation from the internetcomputer.org website. You're going to want to go to Develop, Developer Docs, and then you're going to want to select the Tutorials button in the top nav bar close to the left of the window. And then today we're going to be using the 0.2 Internet Computer Terminology module that is in Level 0 Pre-Flight Operations. So this page of documentation provides all of the written definitions that we'll be looking at today. And this is a great reference to come back to if you need to refresh your memory on what one of the terms means or if you need additional context. For this video today, though, I've prepared a short slideshow that just goes through these terms with a little bit more visualization than just writing the definitions on a documentation page. So to get started, we're going to take a look at a screenshot from the Internet Computer dashboard. If you remember from the previous module, the dashboard shows where all of the nodes on the Internet computer are located geographically. Remember that the blue circles indicate the geographic location of nodes, and they do not necessarily indicate an entire subnet. So, for example, this circle in the bottom left here could be 3 nodes, but they could be 3 nodes all located on different subnets. So if we take a look at the group of circles in the left-hand side of the screen, it's another example of a geographic grouping of nodes. Now, I will again reiterate that that doesn't necessarily mean all of the nodes are located on a subnet. So what is a subnet? A subnet is a collection of nodes that operate an independent instance of the blockchain network by running their own implementation of the consensus algorithm. So we talked a little bit about that in depth in the previous module when we looked at the subnet portion of the Internet Computer dashboard. So when we're talking about subnets and nodes, we're also going to be talking about the replica, which is a collection of protocol components that are necessary for a node to participate in a subnet. So the replica is going to be a bit of software from the Internet computer that a node is going to download and run in order to be part of a subnet and thus part of the Internet computer. A node is a hardware device that runs a version of the Internet computer replica, and it participates in the network by hosting canisters. And I talked a little bit about canisters in the previous module, but we're going to go a lot more in depth in their definition and their components in this module. To reiterate, a canister is a type of smart contract computational unit that bundles together both code and state. Now, when we have subnets, canisters, and nodes, they're all going to communicate between one another using messages. And so a message in regards to the Internet computer is data sent typically from one canister to another, or it's data sent from a user to a canister. So if a canister is hosted on one of the nodes in a subnet, then it's hosted or replicated on all of the nodes within that subnet. Then the canister can receive a message from a user through a traditional web browser or through the command line. It can send the message to another canister on the same subnet, or it can send messages to canisters on other subnets using chain key cryptography. So let's talk a little bit more about canister components and terms. To get started, the diagram here on the right starts with what is known as a canister ID. This is a globally unique identifier for a canister that can be used to interact with it. Next, we have what is known as a controller principal. So a controller of a canister can be a person, an organization, or another canister. They're identified by what is known as their principal identity. We're going to talk a lot more about those. It is important to note that a principal can be used to identify a canister, an individual, or an entire organization. Next, we have the canister's wallet. In regards to canisters, the wallet refers to the cycles wallet for the canister. So if you recall from the last module, I briefly talked about cycles and what they're used for. To reiterate and refresh your memory, cycles are used to pay for the canister's resource consumption. To refresh your memory, cycles are used to pay for the canister's resource consumption. Next, we have the smart contract. So the smart contract, in terms of the Internet computer, is going to be the canister's application code. They are going to be stateful programs designed to automatically execute, control, or document events and actions according to the configuration of the contract. So the smart contract in this context is going to be what powers your application. Last, we have the canister state. The entire state of a canister at any given point is considered the canister state. It's divided into two portions, the system state and the user state. When the canister state is changed, this refers to the result of any operation, function, call, or transaction that changes the information that's stored within a canister. So to talk a little bit more about the architecture of a decentralized application on the Internet computer, it is important to know that there are several different types or categories of canisters. So because a decentralized application refers to a canister or several interoperable canisters that provide a service or a program that has been deployed on the Internet computer, it's possible that there are several different types of canisters that serve different functions. For example, the biggest category of canisters are backend canisters. These contain the application's core logic code. These can be written in Motoko, Rust, Hazel, Python, or any other programming language that can be compiled into WebAssembly. They typically use actors, which is a process with an encapsulated state that communicates with other actors that are concurrently running. These actors can communicate through asynchronous messages that are received sequentially. Actors then can modify their own private state, but they can only alter other actors indirectly through messages. An example of an actor code is the screenshot in the top right, which shows the actor definition for a backend Motoko canister. This provides a very simple function that returns hello and then the text input. In this case, it is a simple echo statement that returns hello and then a city that is passed as an argument of the function. So backend canisters can be interacted with through Candid, which is an interface description language that is used to describe the public interface of a service in the form of a program deployed as a canister. So in the bottom right, there's a screenshot that shows the Candid UI, which is a user interface that can be used to directly interact with the backend canister's defined methods and functions. Next, we're going to talk about the other types of canisters in addition to backend canisters. Typically, a lot of applications will have a backend canister and a front-end canister. The front-end canister is used to host the user interface for the application and is typically written in a framework like JavaScript, Rust, HTML, CSS, or other UI frameworks. They typically use agents, which are libraries used to make calls to the Internet Computer Public Interface, and that's typically how front-end canisters will communicate and transfer data to the back-end canister. Front-end canisters are also known as asset canisters since they hold the front-end assets of the application. Another category of canisters are custom canisters. So these are types of canisters that don't fit into the back-end or front-end type definitions. They may be used for specific individual functionalities, or they may combine both front and back-end functionalities into one canister for simplicity and ease of development. Lastly, we have system canisters. A system canister is a pre-installed canister that is used to perform a specific task that helps to maintain the Internet computer specifically. So the NNS and the Internet Identity canisters are examples of system canisters on the Internet computer. And on the right, there's a screenshot of a very simple front-end canister that is used on a simple voting poll application. And we're actually going to be building this application in a later module in the Developing Your First DApp module in level 1 of our developer journey, which is the next level. So now let's talk a little bit about how canisters communicate between one another. When a canister is hosted on a node, it can talk to another canister through a query call or an update call. First, it's important to understand what execution means in the Internet computer. In reference to the IC, execution refers to the execution layer, which we briefly talked about in the previous module when we talked about the protocol stack. But the execution layer is responsible for executing the canister smart contract code. And like I mentioned, execution is done via WebAssembly. When a canister's code is executed and it needs to perform a call to another canister, it may be a query call, which is a method that's used to execute operations on a canister. Queries are performed synchronously and they're made to any node that hosts the canister. Consensus is not required to verify the result of the query, so it could possibly return information that may be outdated or unverified. An update is a call that is performed asynchronously and it goes through consensus since it will change the state of the canister that is being updated. All canister calls contain a principal, which is an entity that can be authenticated by the Internet computer. Recall that in the slide talking about canister components, I mentioned that a principal can be anything on the IC that can be authenticated, so not just a canister principal, it can also be a user's principal or an organization's principal. To talk a little bit more about cycles, so canisters pay for their resources such as CPU, memory, bandwidth, and other resources for both execution and canister calls that are performed on the Internet Computer Mainnet network through the use of cycles. So the Internet Computer token, which is the network's native token, can be converted into cycles using the current price of the ICP token measured in XDR. XDR is a standardized form of currency that is maintained by the International Monetary Fund, and so it's very similar to a stable coin. And the conversion rate currently is 1 trillion cycles corresponds to 1 XDR. So next we're going to talk a little bit more about tokens and other tokenomic features on the Internet computer. First, we're going to talk about ICP, which, like I mentioned, is the native utility token of the Internet computer. It can be used to participate in the network's governance through token staking on the NNS, and it can also be used to be converted into cycles, which then can be used to pay for the canister's resource consumption. On the IC, the ledger canister is a system canister used to store accounts and their corresponding transactions. So if you make a transaction where you send ICP from one user to another, the ledger will have a record of that transaction. So a transaction on the Internet computer is any process that is transferring ICP from one account to another. It can be a typical transfer transaction, it can be a minting transaction that is minting new ICP, or it can be a burning transaction where ICP is essentially destroyed. So now talking more about the NNS, there is a screenshot on the right here that shows the NNS dashboard, which we looked at in depth in the previous module. And we're just going to revisit the definitions of the NNS and what the NNS and SNS are. So the NNS is a decentralized autonomous organization, or a DAO, which is a form of governance where there's no centralized form of authority. So decisions are made by stakeholders, which are usually determined by staking the DAO's token, like on the NNS, and staking ICP and a neuron. And voting on decisions are all proposed through the DAO. Another key component of DAOs is that all activity is executed on chain in order to provide a transparent and verifiable record of activity. So everyone who votes and has staked tokens on the NNS can see a record of how currency is moved, how decisions are voted on, and the outcome of different proposals on the NNS. So the IC is governed by a DAO that's known as the Network Nervous System, or the NNS, and it also offers decentralized applications on-chain to be governed by what are known as SNSs, which are app-specific versions of the NNS. So any app on the IC can apply to be an SNS and then be their own decentralized DAO that is controlled by the dApps community. Any changes or updates made to the NNS or any SNS are made through proposals, which are a statement that describes a suggested modification in any aspect of the IC or any of its subsystems and sub-applications. Next, it's important to cover a couple cryptography terminologies. So a certified variable on the IC is a very important cryptography term and component. It is a piece of data that a canister stores in the subnet's canonical state during the processing of an update or an intercanister call. So this data is used when a query call is made so that the canister can return a certificate to the user to provide the data's value. So that might seem like a lot of words, and we will definitely dive deeper into that and look at a hands-on example in a future module. But the important takeaway from that definition is that typically an update call goes through consensus, and so the result that's returned from that update call can be verified since all of the nodes on the subnet verified that the value of the update returned was correct. A query call, however, does not go through consensus. So like I briefly mentioned when we were talking about the definition of query and update calls, they may return outdated data, they may return data that isn't validated. To help alleviate this and make query calls more verifiable, certified variables are used, which start off as an update call, and then they're stored in the subnet state and then can be retrieved using query calls. So they are a really useful function that is on the IC. And like I said, we're going to dive deeper into a hands-on example in a later module. Then the next term we have is chain key cryptography, which is an array of advanced cryptographic mechanisms that allow the IC to achieve scalability and functionalities that just aren't possible on other blockchain networks. These cryptographic protocols help orchestrate the nodes that make up the internet computer and help provide new functionalities and workflows such as CKBTC, or chain key Bitcoin, to enable Bitcoin workflows on the IC. And in the future, it'll also be expanded to Ethereum and CKETH. So that's going to wrap things up for this module of the developer journey. In the next module, we're going to set up our developer environment. So this is going to consist of confirming that we have a couple prerequisites like an internet connection and access to a command line interface. We're going to take a look at downloading some of the tools and packages that we're going to need in our developer journey. And we're going to assure that everything is up to date and ready to go so that we can dive right into developing our first decentralized application on the internet computer.
Okay. I'm sure you picked a few things from there. We will share the documentation in this video as well if you would like to watch it like on your own as well. after this call, share like via the email and on Telegram. So okay. Yeah, so just a few terms that were highlighted in the video we just watched. The dashboard, the internet computer dashboard is one important thing you need to familiarize yourself with and um, use really well. It will come really handy. My internet is so slow. Let's wait for my internet. Okay. I'm not sure if it's my internet or something else. Okay, let's look at the NNS tab and see. Okay, yeah, so I think there's something happening with the dashboard. So I mean, this is the NNS application, network nervous system for the internet computer, right? Where you can make some transfers of ICP by ICP, take some neurons, do 14. You can see some proposals that are here, some IC proposals. Yeah, there's this launch pad, canisters, your own connected canisters. So for you to start doing anything, you need to sign in with internet identity. So the internet identity is an authentication system that was created for internet computer dApps. It's centralized application, right? Which allows you to authenticate into application in the internet computer without the need of password or there are seed phrases, but like they work in a different way than than other blockchains. Here, like you can actually connect your internet identity to your phone, and like it's so convenient. Once you set it up one time, store your seed phrase safe. You can use it across multiple devices, yeah, so easily. So let me indicate. I'm actually using my phone. I can use this computer itself, or you can use passkey, whatever you have. So yeah, this is my ICP balance on this wallet. You can see all these other you highlighted, she said CK chain key will like move on to CKE. Like this video is kind of old. I mean, CKE is already live on the internet computer. You can already see it. using chain key cryptography. And we have here CKBTC, and we have all these tokens from applications of the ecosystem. We have this open chat. If you know open chat, this decentralized chat application, like similar to WhatsApp, but it's completely decentralized. So open chat is an SNS, it's a DAO, right? And we have Boom DAO. This is a gaming platform where you can build and deploy games on the internet computer, and all these other tokens for different projects. So yeah, this NSS NNS application, it can serve like just as a wallet for you. Yeah, the neuron, you can stake some ICP, and then you can start, once you stake some ICP, or you buy some neuron, and then you create your own neuron, I mean, and then you can start contributing to the ICP DAO. Like, you'll be able to start voting and contributing to the network. Canisters, if you have some canisters, wallet canister, whatever, they are not only created from the command line. You can actually create canister here for whatever purposes you will be have. And then yeah, this dashboard, I think it's working now. Yeah. So here on the dashboard, you can search for transactions, or you can search for canisters like this. I'm sure this is the ledger canister. Yes. So this is the SNS ledger canister. So here, once you put like a canister ID, it shows you the interface of the canister, the functions that are exposed by the canister. You can actually see the types, Motoko, Rust, the types and the functions of that canister. So whether the canister was built in whichever language, once it's running on the internet computer as a WASM module, its interface will be, you'll be able to see its interface here and like see and verify whatever you need to verify about the canister. The controllers, all the information will be here. And then we move on to, okay, before we move on to setting up the developer environment, are there any questions at this point which we can discuss? Yeah, looks like there are no questions. So
I believe there's a question in the chat.
oh, there's a question in the chat. Okay, sorry. What about Bitcoin inspired ICP? Can you expand your question? Like, if you can unmute and really, I'm not really understanding it. Arnold.
Hey, can you hear me?
Yes.
Yes.
Yeah, I was just trying to think out loud. I'm trying to understand the ICP's infrastructure, and maybe I thought that you guys or the people who designed ICP were inspired by Satoshi and how he wrote the Bitcoin white paper. So are there any similarities in the white papers? Or do they serve
Okay.
completely different purposes?
Okay, cool. So ICP, like the Definite Foundation, started with Dominic Williams. He was in the crypto space for some time. He wasn't, like, from what I understand, from my understanding, of course, Bitcoin is great, but the idea that prompted him to actually think of the idea of the internet computer was mostly about Ethereum, like with the smart contracts on Ethereum, right? Where you can't hold a lot of, it's just like the smart contracts, you can't do nothing much on smart contract on Ethereum in terms of storage, and also the issue, like in the Web3, we want to be fully decentralized, right? But it's at that point, it was impossible to try to have a fully decentralized applications. So his idea was to try to have like a world computer, a world supercomputer where that is decentralized, where you will be able to build full applications that are completely decentralized, and also and kind of, we can say is what can I say, the competitors exactly are like these big tech companies, that owns data, Google and Facebook, whatever you name them, and these cloud services, AWS, right? But in the Web3, we didn't have that. Like you can want to create a decentralized application, but it was impossible for you to have a fully decentralized application. So the idea was to have a decentralized cloud, let's say, where you have the freedom, you have all the benefits of Web3, the security and everything, but at the same time, you are able to build scalable applications that runs at the web speed, but still in a decentralized manner. So the inspiration, if I can try to summarize it, was just so that we can have like a truly Web3, full complete Web3 infrastructure that allows you to build 100% applications that are running on the blockchain. Yeah, you should like check him out. You should watch Dominic Williams and kind of understand his vision he had, and the problems he had with these big tech companies, and trying to get to the point where we have complete full Web3 and decentralized ecosystem. So if you were in yesterday's session, as we were saying, like if you're building, like let's say on Ethereum, it's impossible for you to have a fully decentralized application. But only on the internet computer, you can now have both your front end, your data, and your business logic. And recently, you can now even have decentralized AI. I mean, models running in canisters, that type of thing. I don't know if you were answered.
Yeah, man.
So
Thanks
yeah,
for the explanation.
sorry.
Yeah, thanks for the explanation, bro.
Okay, yeah. Look him up and just the Definity Foundation YouTube channel on YouTube. Definity Foundation. You should like check it out. You will learn a ton of things from there. Okay, so is there anyone who is like willing to volunteer like share their screen, and then we can try to do to install some tools while we're in this session, so that others can also
Sorry,
see.
give me a sec. I'm opening up my Mac.
Okay, cool. Thanks.
I mean, unless someone else wants to share, I guess.
Okay. Okay, go ahead, Afikile.
Good afternoon, everyone.
Hi. Yeah.
Can everyone see my screen?
Yes.
Okay, so I don't know what I'm supposed to be doing.
Okay. Cool. Okay, you're on Windows. So on Windows, it's not as straightforward. There's just a few steps you need to do. You need to install WSL, paste, or Docker. WSL or Docker. Are you
At a tab.
familiar with Docker or WSL? Which one are you familiar with? Okay, let's go with WSL.
None of
I think it's the easier one. Yeah, just type WSL. WSL installation. Yeah. Okay. Let's say install WSL command. Yeah, so open your PowerShell and run that command.
work if I have command prompt or
Yeah, it's fine.
okay, let me copy that thingy. Okay, not recognized.
There's an external. Is this PowerShell?
No, this is command
No,
prompt.
I tried to open
that
PowerShell.
was yeah. Oh, in it Linux. Okay.
Just type, I think, PowerShell in your search bar. Yeah, now run that command again.
Still not recognized.
Mm, okay. Let's go back to, we have to install it in a different way. Or okay, we can even install it from the store, the Microsoft Store.
Microsoft. Okay.
WSL.
Which one is it? Is it this one or just the normal WSL?
Click that one with like 22.04 LTS. Open the one with 0.6 LTS.
This one?
22. Sorry, 22.04, the one at the top. Yeah.
Okay.
Okay.
Still it's taking
It's taking
the
time.
time.
So
Yeah.
let's give it time. Let's give it time. I think Ben, you can join and then we can also do on yours as well.
I've installed it.
Oh, then they can share then since.
Okay, yeah, you can stop sharing. What did you say, Ben?
I've already run the installation.
Oh, you've already done the installation. Okay. Okay, it just quiet like so that we can see you like try to spin up the canister and everything. You're sharing. Okay. Awesome. Can you just type DFX? Okay, it's already working, I guess. Okay, DFX new and then give the project you want, like the name of your new project. But that error, maybe you might want to restart your terminal. I don't know. Yes, you can do with Docker as well. Even though myself on Windows, I use Linux, but on Windows I haven't used Docker. I've been using WSL, but let me there's actually a guide, a small guide to do it with Docker or WSL. Let me send you the documentation now. Okay, error is still persistent. I think let's ignore it for now. So can you do DFX new? Can you run DFX new? And then the name of the project you want to create, maybe Hello World or whatever. Space new. I should give it the project name. Yeah. It should have an underscore or it's proceeded, it's fine. I go with Motoko. Yeah. What's your favorite there? React, I guess. Yeah. And that just to enter internet identity. So it creates the project and then installs some initial. I'm not sure about that error. So yeah, project's done. You can do CD hello world and then open it in VS Code if you use VS Code. Yeah. There you go. So just in case you would like to go with Motoko, install the Motoko language support. What is it? Yeah, that one. Cool. Yeah, you can go to the files there. So that's the project, open source. Yeah, it's with the backend, the main.mo file. So this is where you'll be writing your Motoko Magic. And then we have the front end, Hello World front end. So this is your React application with Vite.js. And then open DFX JSON. Yeah, some assets. Yeah, so another important thing, can you open in public that one? Yeah, open it. Just click it again.
Hello. Can you hear me? Hello.
Yeah, I can hear you.
Sorry, my power just cut randomly. I don't know what's up. I need to go see what's happening.
Oh, okay. I even refreshed. I thought I was the one who's frozen. Okay.
Yeah, no, sorry. What
Okay.
the power's back now. I don't know what's happening.
Oh, okay.
Yeah, otherwise, can you help someone else so long? Otherwise, I need to wait for my Wi-Fi to reboot.
Okay, cool. That's fine. Afkila, did you finish downloading?
I think it's because it's the network traffic is very slow because it's not even halfway through as yet.
Oh, okay. Okay.
Yeah, it's taking forever.
Okay, that's fine. Anyone else with like Mac or Linux? That will be faster. Okay, that's fine. So I think yeah, to maybe tomorrow we can, if Ben is here, we can continue with Ben, and I think I hope he also would have installed as well. So okay, let me just share my screen and show you some documentation where you can get some instructions, and also we'll send you the documentation as well. So on the Internet Computer website, come to developer docs, and then build, and then here you can see installing tools. So this is where you have the guide on how to go about it. So this bootcamp will be long, so we can just as well do it the proper way to install the tools on your local machine. Otherwise, another alternative would be to use like Gitpod or a GitHub code spaces, and then just like quickly run the thing. But since we are not rushing and we have a bit of time, we can just set up properly on our local machine. So you just come to this documentation, build, and then installation tools, and then you follow these instructions. So yes, for Mac and Linux, you go like this, and then for Windows, it's here. So here's a small guide for either Docker container or WSL. Yeah, so just follow this documentation, and if you face any errors or any hiccups, just reach out to us and we can have like a one-on-one call with you guys and help you out. And then yeah, tomorrow we'll see what we can get on. And then here there's this documentation for cycles. I think I also sent this on Telegram. If you just want, for some reason, you just want to have your cycles, it usually takes a few days or so, the process. So yeah, go ahead. Go ahead, Afikile. You are still
I
muted.
wanted to ask if. Oh, can you hear me?
Yeah, we can hear you now. Yeah.
Oh my word. Can you hear me?
Yeah, we can hear you.
Okay. I wanted to ask if Telegram was the only form of communication because I wanted to check some notifications today and I got a notification saying my number is banned.
Hmm.
Did you hear my question?
Yeah. I heard your question. Okay.
I'll just type it in the comments.
But we heard your
Oh,
question.
okay.
Can you hear me? I think there's some problem.
Yeah, I can hear you.
Okay, I was saying we are also doing emails, but they are not as quick and as frequent for updates. Yeah, and Telegram will just be quick, but yeah, we'll also send some emails, but I don't know if you can. Telegram would be the best and fast and easy for you to get the notification, the updates. But yeah, if you have your emails, have you been receiving emails we have been sending?
Okay.
Have you been receiving emails?
Yeah, I have. I'll just try and check with them on what the issue might be.
Okay.
Yes, I
Yeah.
have.
Okay, cool. That's fine. Okay, so guys, I think our time is ran out. So we meet tomorrow, you guys. Okay, so here on cycles, I was just saying, okay, let me share my screen just one more time. Show you what I was saying on cycles. I was just saying you can check out this documentation, and then for whatever the project you will build for practice and potentially in the hackathon, it's good for you to be familiar with the entire flow, getting the cycles, deploying live, even buying your own cycles, whatever you want. So these are the other documentation we'll share with you. So if there are no questions, I think we can call it a day and meet tomorrow. Any questions? Okay. That's fine. Thank you guys for joining in. Thank you, Beam. Thank you, Afikile, sharing your screens and helping out. we meet again tomorrow. Good night, everyone. Should we have everything stored for tomorrow? It will be okay, but it's not like a prerequisite. Yeah. Cool. Okay, so good night, guys. Bye.